We have x and y defined parametrically as x equals e to the t and y equals t times e raised to the minus t. And we're supposed to find this derivative, dy dx. Well, we know that in order to do that, we'll take dy dt and divide that by dy dx. So what we're finding then is the derivative of this function t times e to the minus t and dividing that by the derivative of the function e to the t. Well, if we're going to find the derivative of t times e to the minus t, then we're going to use the product rule. And we'll just go the first function t times the derivative of the second, and the derivative of e to the minus t is going to be minus e to the minus t. And then we'll add to that the second function, e to the minus t, times the derivative of the first. And what we can do is we can factor out an e to the minus t. And we'll wind up with 1 minus t. Divided by then the derivative of e to the t, and the derivative of e to the t is just e to the t. So we can bring the e to the minus t down to the bottom, and we'll wind up with e to the 2t. So then the derivative of y with respect to x is just going to be 1 minus t over e to the 2t. Now, in order to find the second derivative, what we're going to have to do is take the derivative of the first derivative with respect to t, and then divide that by the derivative of x with respect to t. So what we'll be doing then is finding the derivative of the function 1 minus t over e to the 2t, and then dividing that by the derivative of the function e to the t. So we have a quotient rule to deal with here, and I'm going to split that out. So this right here then is going to be just the derivative of 1 minus t over e to the 2t. So we're going to do the bottom times the derivative of the top, so e to the 2t times minus 1, minus the top, 1 minus t, times the derivative of the bottom, and the derivative of e to the 2t will be 2e to the 2t. And then we divide that by the square of the bottom, so e to the 2t squared. And again, we're just doing this part here. We'll worry about the derivative of e to the t in a second. So we are then going to simplify by taking out this e to the 2t that we see appearing in both terms. We have two terms separated by that minus sign. So we'll factor that out, and we're left with the minus 1 minus 2 times 1 minus t, and then that'll be divided by e to the 4t. When we raise a power to a power, we multiply the exponents. And what will happen is that e to the 2t and this e to the 4t are going to reduce to an e to the 2t in the bottom, and we're just left with the top now, minus 1, and if we distribute that 2, we'll have minus 2 plus 2t. So we have 2t minus 3 over e to the 2t. Now that's this derivative, the derivative of dy dx with respect to t. So that's here, 2t minus 3 over e to the 2t. But we still have to find the derivative of x with respect to t and then divide that out. So we're finding the derivative. We found the derivative of y with respect to x with respect to t, and now we're finding the derivative of x with respect to t and dividing that out. So we have 2t minus 3 over e to the 2t over e to the t, because that's the derivative of e to the t. And this is just going to invert and multiply and give us 2t minus 3 over e to the 3t. Now we're supposed to find when this thing is concave upward. Well, it'll be concave upward when the second derivative is positive. So when d2y dx2 is bigger than 0. Well, e to the 3t is always bigger than 0 for all t, because we have a positive number that we're raising to a power, and we can never change the sign of that with an exponent. So really all we're concerned with is when is the numerator bigger than 0, and solving for t, then we just have that happening when t is bigger than 3/2.